Today, we're going to introduce Seattle Parking Fact Finder, which is designed to aid planning decisions. Seattle is currently facing a challenge of oversupplying street parking. Complaints have been made from the local residents saying that the street parking is more than real needs. The annual parking report indicated that there were in total 13,000 parking spaces, and the average parking occupancy rate during rush hour is 77.8%. Note that most of the study area are in the downtown, which means even the busiest area in rush hour is not fully occupied. So we started to look for factors that may affect the occupancy rate and found that occupancy rate varied in different land uses. However, currently, there is no convenient way for planners to know how the parking requirement would change if a certain area's land use changed. Now is the way for the planners to know which area is generally considered to be oversupplied by the citizens. The Seattle Parking Fact Finder is designed to meet the demand. It is an application that could predict the occupancy rate of a certain street segment in rush hour as well as normal time. For citizens, they could use the app to check if their street is oversupply parking by comparing the prediction with the current situation. For planners, they could easily check on the app to see what the parking demand will change if they change the land use type for a certain street segment. This is the workflow of our app. Citizens could use this app to make evaluation, whereas planners could use this app to make decisions. Let's see how the app works. First, set up your account as planners or residents. If you choose as residents, you will log into this page. The home page will be a map showing general occupancy rate of street segment or zoning area. Residents could either choose on the map or input the street that they want to zoom in, and then they will get to the page showing the prediction of that street during peak hours and normal time. The arrow indicates whether the prediction is below or above the current supply. Based on a prediction, citizens could make an evaluation about their street. Citizens could either go back to the formal page. Then for the planners, the homepage would be the same, but they will have an additional function as customize a prediction by given land use type. They could input the planning street location or search on map and either input or search for a desired zoning type. If you choose residential, for example, and press go, you will get a prediction of the current zoning code and a prediction of the target zoning code. By comparing the current supply as well as the satisfaction of the residents, planners will have a better understanding of the real needs. Here's part of the dataset that we use in our model. First is census tract data with demographic information. Another is zoning code. Here's a scatter plot showing some of the continuous variables, such as average building height and segment length. Here's a histogram of the dependent variables. As we can see, the distribution of the occupancy rate is generally normal, and there's a linear relationship between the independent variables and the dependent variables. So we will choose OLS regression as our model. Here are the regression results of the model. The MAPE is 0.23, relatively low, and the map of residues shows that the residues are not clustered, so our model is quite robust. Here is the cross-validation result. The mean absolute error is 0.21, relatively low. And if we took a look at the predicted value as a function of time, it shares the same trend as the observed value. Again, our model is quite robust. Here is the spatial validation result based on different zoning area. As you can see, our model performed quite well in the mixed-use area, but not so good in the industry area. The main reason is we got enough data in the mixed-use area, but not so much data in the industry area. Conclusion. Our model is relatively robust in terms of the low MAE and the residues. However, the parking study data that we use in this regression is only available for a few neighborhoods, which affects the generability of the model, as can be seen from the spatial cross-validation. Our next step would involve working on the app to make it more user-friendly, useful, and practical for the citizens. Thanks for listening.